Okay, so 2.7, day 2, we're going to use our calculator to help us out a little bit, but you still have to sketch on the paper. We had to take the second inequality and solve it for y, so we could put it in our calculator by subtracting over 4x. So you need to hopefully have that on your paper because, like I said, it's going away. In your calculator, how do I graph something? You go to y equals. So go to y equals and put them in your calculator. Do not put everything that is on my screen because I have other equations in there. The top two should be what you have written on your paper. Okay, what do I do before I graph? Zoom 6. The zoom 6 is because you are today going to be messing with this screen, so you want it back in the middle every time. Okay, I need to know where these two things intersect, and then I'm going to have to do some shading, right? So, what? If you have the right things in your calculator, if you have negative 2x squared plus 12x minus 10 and 4 minus 4x, did you hit zoom 6? Well, it would tell you you're wrong if you put a negative. It should have. Yeah, if it says error syntax, you put a subtraction instead of a negative.
Oh, I see what I have done.
But you put plus 12 minus
It's
10.
plus 12x. No, you didn't. Not in your calculator. Okay.
There we go. Mine doesn't have the
What? So you didn't square it. If you don't put it in right, you're not going to get the right answer. If it doesn't look exactly like what's on your paper, it's not right.
How do I get those boxes? There's a whole bunch of them. Now they're not in my phone.
Because you're Okay, when you go to y equals, is one of these black up here where it says plot? Go up over it and hit enter. Now go back down after you hit enter. Did it go white?
Yeah.
Now go back to your graph. You have stuff in your stats from when we did it before. Okay. You haven't shut off. Okay, so now does everyone have this picture?
No. Mine isn't not okay. What's inside?
Did you hit zoom 6 before you graphed it?
Yeah.
Okay. You have negative 2x squared plus 12x minus 10 and 4 minus 4x.
Yeah.
Hit zoom 6 again. I would say the subtraction you put a negative on probably. You have a negative in the front and a subtraction on the subtraction. So one's little and one's big.
Yeah.
Let me see your calculator. Well, your plot is on first of all. Guys, go to your y equals. If the plot 1 is dark, it cannot be dark. Go up to it and hit enter and go back down.
I'm on top one.
Okay, you need to get off of it. Okay. That was your problem.
I don't
Okay, it didn't want to on hers. Okay, now does everyone have this on their?
Yep.
Okay, what is the problem with my picture? What do I need? I need where they intersect. And we know the way that is, that has to intersect how many times? Twice. So we need to see that. So what do we need to see more of? No, what do we need to see more of? The y's, the negative y's, right? So if we don't know where to go from there, there is, if you hit zoom and you hit down arrow, you see the fit? And you hit zoom fit and hit enter, the calculator will kind of pick a window. Now, I don't think I needed to see that much. Do you? Okay. Now, everybody's fit might be a little different, okay? Everyone's fit, the calculator may have picked a little bit different window. I don't think we needed this much negative y's. Do you? No, because we're like, mine at least, I'm like, oh, I'll go this way. I'm like clear down to like negative probably 200 and some. Oh, we're going to get 300. Do I need to see negative 330? No. So I'm going to go to my window. And you see how I have negative 10 to 10 on my x's? Okay, I don't need negative 230 or 330. Where do you want to go? Negative 50. So use your negative key, not the subtraction. 50, and hit enter, and then hit graph again. Do you have a better picture?
Yep.
Could I have less x's if I wanted to? Yeah, okay. So now I'm going to use this to sketch it on my paper, but there's some things I need to know. First of all, if this was equals, my answers would be the intersections, correct? It's not equals, but I still need those intersections, don't I? Because they're still important points. Do you guys remember how to get those intersections? Trace, second trace. Second trace is calculate. That means I'm going to have my calculator do everything for me. So what am I looking for? Intersect. So number 5, you can arrow down or just punch in 5, either one. Second trace. Now at this point, don't start pushing buttons, look at the calculator. On your screen in the upper left-hand corner, you should see the equation you're on. If you're not on this one, don't worry. Okay? If I'm not on the right one, I can hit my up and down arrow and look what happens. What's it doing? It's switching. If I had 6 equations, I'd move between the 6 by hitting up and down. And the bottom right left-hand corner, it says first curve question mark. It doesn't matter which one you're on, hit enter. What did you notice about your equation? It switched and it says second curve. So guess what? Hit enter. Now it wants a guess. What were we finding? Mine's telling me what I'm finding. Yours is not. So you have to remember what you're doing. What are you doing? Intersect. So you're going to move your cursor. Now you're going to go left or right towards the intersect. It doesn't have to be right on it at all. It just has to be close to it. And hit enter. You should get what? 1, 0. So write 1, 0 down. You might want to label intersect 1, 0. Now I need to find what? The other one. So how am I going to find it? Second, calc, number 5. And it says first curve, hit enter. Second curve, hit enter. And then it says guess. You have to move your cursor towards the intersect you want. Because if you don't, guess which one it's going to give you again? The same one. You have to be closer to the one you want than any others. So I just move it sideways over towards it. There's my guess. And you should get 7, negative 24. Okay. So what else do I need? Because the intersects are going to give me my linear line. That's going to be great and wonderful, correct? I know this quadratic equation opens down because it was a negative 2x squared. But what else might help me draw a better picture? Well, the range, but the vertex. Yeah, the range, the vertex. So I'm going to do what to help me find that? I can hit trace. Watch. Hit trace. See if you can get there. You can guess, right? Is it going to get exactly? No. So second trace, it's going to be a minimum? It's going to be maximum. If you hit minimum on this, it's going to tell you, not right. So we're going to get a maximum. And it says left. So guess what you need to move your cursor to? To the left of what? What are you finding? The max, the vertex. So you need to be left of the vertex. It doesn't matter where, just left of it. Hit enter. Then what's it say? Right. So you move it to the right. Doesn't matter where, just to the right. And hit enter. Now it says what? Yes. You need to move it at least one in. I love it when people give... What you did is you just made the calculator a domain. You're saying look between these two domains for the answer. I love it when people hit over here and it says syntax error. Or it says no sign change. Or it says, you can't do that, dummy. And I go, why? Well, where did you just tell it to look? You told it to look in between here, correct?
Yeah.
And then you guessed outside of it. Does that make sense?
Mm-hmm.
No. So hit just at least once. You can hit more if you want. It doesn't have to be a good guess. And 2.9999985 is pretty much what? 3. So 3, 8. So we've got some information to graph this, right? So let's see if hopefully this will let me do this. So on your paper, we're going to sketch what you see on your graph. So you have your calculator. I cannot have my calculator. Maybe I can have both. We'll try it. We'll see if this works. Really freeze up my computer here. Okay, so we got to sketch this onto here. Now these were inequalities, yes? When they're not equal, it's a dashed line. And both of them were, one was less than and one was greater than, correct? So we've got to do dashed lines when we do this. So we're going to give yourself a coordinate plane, right? And we knew that it intersects at 1, 0. And then 1, 2, 3, 4, 5, 6, 7. And negative 24. Look at that negative 24. This is so to scale, isn't it? Okay, so I know it needs to go through those 2 points. I always find it easier to do my linear first, just because. So I go linear. And remember, it's a dashed line, right? So it goes there. So that's my linear equation. And my quadratic is going to go through these 2 points. And also we found the vertex at what? 3, 8. So we're going to make this 8. And 1, 2, 3. And up to 8. And it was negative 10, right? It was y is less than negative 2x squared plus 12x. I was trying to move my plus 12x minus 10. Yes? I don't know if I'm going to be able to get both of you there. Okay. So I know I have to cross at negative 10, so somewhere down here. So I have to go through here, here, and cross here. So I didn't find my my other x-intercept, so don't worry too much about it. I probably should have done something like this. And I put a little line here and right next to it. negative 10. How did I know this was negative 10? Because if I plug in zeros for all these x's, I get what? Negative 10. So I have this, and then I had y was greater than 4 minus x. 4x. Yes? That's what you should have written on your paper. So I need to know where to shade this. I could shade it in here. I could shade it down here. I could shade it all around. I mean, there's lots of places I could shade, so I need to know what works. I always like to just check inside my parabola first. So we need to test a point. Just like we've done in the past, we need to test a point. What point would you like to test? 4, 0? You gotta have a point. So 4, 0? Okay. So we want to test right here. So 4, 0. If 4, 0 works for both the parabola and the linear equation, I'm going to shade in here, correct? You see that? Okay, so we're trying 4, 0. So when I plug 4 in for x, 0 in for y. So I have 0 is less than, well, 4 squared is 16 times negative 2 is negative 32 plus 48 minus 10. Yes? So that would be negative 42, so that would be 6. Oops. So is 0 greater than 6? Yes? Okay, so we know for the parabola it's all going to be under here. We know that. But we don't know if it's going to be above the linear line or below the linear line, do we? So now we plug it in here. So 0 in for y, and I have 4 minus 16. Is that less, 4 minus 16 is negative 12. Is that less than 0? Oh, is that greater than 0? I think I read that wrong. No, this one should be greater than, shouldn't it? Is it greater than 0? Oh, wait, is 0 greater than it? Sorry. Saying that all wrong. So it is. So that works. So if this point at 4, 0 works, where is it all solution at? Inside here. So you can use your calculator to help you get there. Make sense? But do I still need to sketch it on my paper and go from there? And this probably should be a little bit more curvy, shouldn't it? So it looks like a parabola, not like a line. So I have lots of, I've got lots of examples like that. Remember this point was what? 7, negative 24. And this point was 1, 0. So if I change this, this is the answer, this whole picture, like the whole picture is my answer to this, correct? What if I change it, I'm trying to get it all in here, to y equals negative 2x squared plus 12x minus 10, and y equals 4 minus 4x. Then what are my answers? No, we graph it. What are my answers? 1, 0, and 7, negative 24. If they are equal, I need to know where these two things are equal, correct? So where does that happen? Where are they what? When they intersect. So if I have inequalities, I need to draw a picture and shade. Get what I'm saying? If I have not inequalities and it tells me I can graph, I just find the what? Intersections. If they tell me I can use a graphing calculator. If they don't tell me I can use a graphing calculator, I have to set them equal to each other, quadratic formula, factor, everything we did yesterday. Correct? Okay. Now, I have one more. I have like 5 examples, but I think one more probably could do it because I think the only thing you need to practice is the calculator, right?
Yeah.
Okay. So an example of what you're going to see, go back down, I don't want you yet, in your assignment is something like this. It says write a system and solve using your graphing calculator. Because I can't put that in my calculator, can I? My calculator has to be what? Y equals. So if I had a problem, which we just had, I'll bring it back up. I had this, right? And right here I had y equals and y equals. I put those in my calculator and it's all good, right? If I didn't have a calculator, how would I solve this? You would set them equal to each other. So guess what we get to do over here? We get to go backwards, correct? So, no, we go backwards. We're putting them into a system. So I have my bracket, correct? Y equals, this is hard, because I don't have it calibrated, because it shut off earlier twice. So y equals 3x squared minus 7x. You and you're leaving off your x's. Plus 4. No, don't hit yourself. Okay, and what? Y equals, okay, hopefully you guys have this written down, because what are we going to do with this now? Put it in our calculator, so go put it in your calculator. And these are equals, so I'm looking for the what? Where they do what? Where they intersect. And I think I already have mine in. Ooh. I would have if I had them in right last time. Nobody caught it last period. It's not wrong. It's just a different. I mean, we didn't do it wrong. We just put in the wrong numbers, right? Yeah. We may have done a different problem. Okay, so we have 3. 3x squared minus 7 plus 4. And 9 minus 2x. You got it in? Okay, now before we do anything else, hopefully you just wrote over yours. Okay, so what I did is I didn't want to get rid of mine, so I'll show you guys how to do it because it might be helpful to you. If I want to leave those there, but I don't want to see them on the graph, you go back over the equals, see it flashing, and I just hit enter and you turn it off, just like you turned the plots off before. It's the same thing. So what that would be useful is, like, you've graphed something and you just can't get it the same as somebody else's, but so you want to have, like, me to look at it or somebody else to look at it, just shut it off and you can use your other ones. I think you have up to 10, don't you? Well, if you want to delete it, that's fine, but I'm saying if you want to come back to it later without having to retype it, you can just shut it off. Okay, before I graph this, we messed with that window, didn't we? So we probably want to hit zoom 6 to get it back to the original so we know where we're starting. We might not like it. We might not like the window we get, but so does yours look like that? Yeah. Okay, everyone good? Now we can see the one really well and maybe that one, but we probably could get a better picture, couldn't we? Yeah. Now we could hit zoom fit on this one, but I don't think we need to, do you? No, because we're just guessing. We're already at 10, so maybe like what? You want 15? Maybe a little bit above it. Do we need to keep seeing so much below it if we don't want? Okay, so are those the X's or the Y's? The Y's, right? So we need to see more on the top but less on the bottom, right? I'm going to put -5 for my minimum, but I don't have to change it if I don't want to. I'm going to put 15 for my max. And I don't think you have to hit enter, but last time they were like, it wasn't working. So hit graph. Okay. Can I see everything really well now? Okay. So what are the things? Because I'm gonna have to sketch it on my paper, right? So what do I need to sketch it? Yes, but what information off the graphing calculator?
Intersect and equal conversion.
And the intersects are our answers, correct? Okay, so I'm just writing some stuff on the paper so I can, when I go to my paper, I have it written down. So how do I get there? Second, trace. And we're looking for the intersects, right? So second, trace, 5, and then just hit enter, and it should jump on its own. And I'm going to go for the top. Somebody else can go for the bottom if you want, or we can do both. It doesn't matter. Okay. So now we're really approximating here, aren't we? Would this be one a calculator would be completely fine to do? Yeah. This would be a quadratic formula problem, wouldn't it? You're going to have a square root in there. So I got an intersect at, so the solutions for this are negative, I don't know.
We took 1 second.
We got sister on what? The X.
I got,
Negative 0.7.
it should be approximately negative 0.7.
Yeah. Are we supposed to put the approximate?
Yeah, well, you can't in a point. Like in a point, you can't approximately. Does that make sense? Like if it's in a coordinate pair, you can't put the approximate symbol.
So how many?
Like,
So like what?
I'll show you something. Okay, read whatever. I'll show you what I'm talking about that when I can show you my screen. Read whatever the direction, or do whatever directions say. Right now, we're going to go 10th. Okay? So our point is going to be negative 0.7, comma, 10.4. Now, I'm going to tell you right now, if you ever give me an answer like that, I'm assuming it's an approximate, and I will show you what I would expect to see if you don't give me a point here in 1 second, okay? Okay, so I now need to get to the other one, so how do I do it? Second trace, okay. 5, enter. Doesn't take too long after you know how to do it, right? So approximately, what, 2.4, comma, 4.3? Okay, what else do I need to be able to graph this? Minimum. Why is it a minimum this time? Because it opens up. I know. So find your minimum. Oh, that's not left. Look what I did. Is it going to work for me? No. So instead of finishing, just hit second trace again and do it all over. You get in the middle and you're like, oh, I screwed up. Just go back. It's not a big deal. Okay, I got approximately 1.2 and negative 0.1. Okay, on this one I probably would have said go to the 100th. Why? Yeah, because it's 0. But whatever it says. Okay, do we have enough information? What? What, Kelly? 1, just 1.2. Because we were doing tenths already. Now, when I draw this, are these going to be dash lines or solid? They're solid because they're equal to, correct? Okay, so we're going to...
So if it's not, if it's like greater than or less than.
If it's greater than less than, you're going to be dashed. If it's greater than or equal to, it's solid, correct? Okay, so now I got to get it lined up again. So what I was trying to explain, and I said I'd show you in a minute, if I'm writing those intersects as a coordinate pair, this is my answer. If I'm writing just the solutions, I have to use the approximately. Does that make sense? Okay, if I say, what is the solution? Right here are the solutions, yes? Because when we write solutions, we write them in terms of the x's only. Because if I have an x, can I get a y always? You can just plug it in and get the y. So if I'm writing it as the solution, right here is my answer. But if I'm going to plot it, do I need this? Yeah, that's what I'm saying. So the approximately on your solutions, but not in your coordinate pair. You can't put an approximately in a coordinate pair. The assumption is that when you give a decimal in a coordinate pair, it is an approximate. Okay, so we need to graph it, correct? So
I just do one line and put one.
okay. No, that's fine. Like I just put 10 instead of 10.4. This is just a rough estimate, right? And I know I should cross where? At 4? Yes? And then my line needs to go through here, yes? And I'm not shading because it's not inequality, is it? If it was an inequality, I'd do exactly the same thing, but then I would test a point, correct? Pick a point inside the parabola. You can choose whether you do inside or outside first. It doesn't matter. I typically always do inside first because it's usually like in the first one we had y was less than. Well, that would be under the parabola typically, wouldn't it? So I do that. Like if this was y is less than, then I would probably pick a point outside here. I like to pick 0, 0, wherever that is. So you just kind of pick a point that's in or outside the parabola. In or outside of the parabola, above or below the linear. And whatever overlaps is your answer. Okay. Do we need to do more? So what is the answer to this problem?
2.4, 2.4, comma 4.3, negative 0.7, comma 10.4.
Nope. This is my answer. Okay? These are solutions. These are what? They're intersects. Same thing, roughly, correct? Just like a solution in an x-intercept, when I'm talking about just a parabola by itself, are essentially the same thing, but it's just how they're asking for them. That's 2.4. Okay? So that's what some of your problems today are graphing, some of them are not. I think most of them today are using the graphing calculator. 26 isn't, 27, 28 are not. They're from like yesterday's stuff. But 27 and 28 are those ACT assessment practice questions. That's it. That's all I got for you.